with an arm extended, with a one motor, you know, do you have the torque requirements? Now maybe you don't even know what torque requirements are, so that's why you've got a mentor, and that's why you've got resources available to you. You can make sure that you do the math to where when you come back to the big group, somebody doesn't say, well, that's not going to work. You know? So your goal here in these little sub-teams for the week after, the week following the kickoff, is to come up with design ideas and then come up with the supporting documentation and stuff that will allow you to communicate those design ideas to the larger group, to the big team. Okay, so the things that you need to do, communicate or critique and eliminate ideas. I mean, that's critical. You don't want to get like lost in just all these different possibilities. So look at all of your possibilities, eliminate the ones that are either way too difficult or maybe way too simple. I mean, we're going to kind of focus on simple this year, so we're going to be really looking heavily at those ones, but you know, just try to get it down to where you're only looking at a few ideas and then really focus heavily on those few ideas. You're going to analyze them and you're going to create prototypes. We already talked about the math. There's going to be a lot of math involved. Weight. You know, if you're looking at a pneumatic system and 10 different motors in your design, and you don't have enough money to buy aluminum, so you're going to do steel. I mean, it's going to start building up. So you really have to start thinking about things in terms of weight and dollars and all sorts of things. Prototypes are key here. I'll just use a quick example. The year that we had the big pneumatic cylinder, the inner tubes, one of the kids on our team came up with this great idea of using like a device that would have two belts that would, if you drive them together, it would suck in the ball, the inner tube, and then you change direction on one of the belts, and it would rotate the inner tube. Well, he came back to the big design after this week of, or the big team after this big week of design work, and he wasn't able to fully communicate his design well enough to get people to understand what he was talking about. His prototype was poorly made, nobody understood it, nobody understood how we were going to drive it, and it just seemed like this unattainable design, like it would just be a nightmare, right? The crazy thing though with this is that when we got to the event, when we got to Portland, that design was there, we saw it was brilliant, and they were the ones that won the competition that year. Okay? What's that? It's the exact same design. And everybody was just like, oh. So had he done the work up front here, and he was able to come to our group and communicate his design well, we could have been that team, or at least competing against that team on the final match, like we had the last year, 2 years, where we came in second place. So it was, like very critical to do this work up front. All right. Prototypes are very, very valuable because they're tangible. You can see it in 3D. You can hold it. It doesn't have to be made out of the real materials. You can make it out of cardboard. You can make it out of duct tape. But put some time into it so it's functional. If it's functional in the prototype, people can realize how it'll be functional on the the end result. Mock matches. This is something you can do during the design review. And that's putting a couple of robots out there and showing people what'll happen. You can do little things like that. CAD animation. Anybody go to the inventor presentation? So the CAD animation. This is an excellent way of showing your design. Probably the easiest one as far as I'm concerned. Okay, it's a lot more difficult as far as I'm concerned to put something together with duct tape and baling wire than it is to just go in and model it really quick. And if you're any good at inventor and you use the chassis design tools that they showed you, it's just phenomenal how quickly you can get something and then animate how it'll work. Okay, so very valuable. If you got some folks that know Inventor, great. If you don't, get some folks. Give them Inventor. It's free download. Get them rolling on it right now. There's tutorials. You need to have someone that can do that. Okay. Annotated sketches. Now this is a terrible one, and you can't see it very well, but it's very important. I can't stress enough the communication component to this design review. If you can't clearly communicate your design ideas, nobody's going to believe that it's going to be a feasible design. Okay? Put a lot of effort into annotated sketches. If you don't have this tool in your back pocket, get some folks to help you. Okay? When you come up with a sketch, show it to someone, say, here, does this make any sense to you? And if they start asking questions, make sure you answer those questions in the form of annotations, little notes with arrows, directional arrows. This is going to move up and down this way. Okay? I don't know, can you see these arrows at all? Yeah. So just make sure that you really fully explore your design so that anybody can understand it. And then, like I said, make sure you get some feedback from folks to make sure that everybody will understand it. So then, within your little subgroups, you're going to try to come up with which are our ideas within our little subgroup are the best ideas. Okay, you might have 2 or 3. It may be difficult for you to decide which one's the best, but try to come up with some kind of consensus on which one is the overall best design. Now you can bring all of the designs to the main group. There's nothing that says you can't, but it's best if you can come in and say, we really fully agree this would be the best design and this is why. Okay? So now we're back a week from the original kickoff. We're on Saturday again, so this would be the 10th. You're going to come back to the main group and you're going to give a presentation. Okay? I'm just going to jump down here. And invite people from your community. Invite the people with the big fat wallet. Invite the people that you know, from the community that might be interested in sponsoring you even next year. Because this is a really cool day. This is where people can really see the work that you've done. And when they see those presentations going on, these professional presentations, when they see students from high school standing up in front of a large group explaining a mechanical process and which materials they're going to use and the math that they did to prove that their design concept is going to work, that's powerful stuff. It makes you get goosebumps from it. So invite those folks, your principal that probably has no idea what you're doing, you know, the school board, your parents, invite all those people. They're going to dig it. It's going to be really exciting. And this is the day to do it on Saturday. Don't do it on Sunday. Do it on Saturday. You'll learn why not to do it on Sunday here in a second. But then make sure in your presentations that you show how it works. This is the how it works portion. Remember before we said, what does it do? This is how it works. Because like I said, with Diego's design, you know, he had this what it does, but he didn't have the how we're going to make it happen. And the how we're going to make it happen was what killed his idea. Because he couldn't explain it. He's like, I don't know, we'll figure it out. Well, when you got over here a really simple design that's very well laid out, and you can wrap your brain around it, and then you got this pretty far out there design with, I don't know, we'll figure it out. Which one are you going to go with? I mean, it's pretty clear. So don't be the I don't know guy. Have it all figured out. Within your design, try to get, again, it's just communicating it. The more you can get people to understand how your design is going to work within the match, they're gonna be able to see that that's going to work well. Okay, so it's your responsibility. 3D designs are great, sketches are great, prototypes. Bring with you the positives and negatives of your design, okay? It's great to show up and be totally thrilled about your design and you're just completely like sold that this is the best design ever. But it's irresponsible to show up and not provide your team with the negatives that you've uncovered about your design as well. With every design, there's going to be negatives. Okay, this is going to be a very tricky thing to manufacture. Okay, let it be known. But we think it's a good design anyway, and we think it's worth the risk. Okay, you're not used car salesmen, so you know we're a team. Make sure that everybody is on the same page. The other thing I'd say at this point here, as you're selling your team to the design or selling your design to the team, don't get too wrapped up in the ownership of your design. And I'll speak from experience in that if you show up and try to present your design to the team and the team doesn't love it and the team doesn't vote on it and it doesn't become the one design, you're going to get your feelings hurt. Okay? And then that could erupt into a big mess.